Okay. Now today we will discuss a different algorithm for performing the arithmetic operation division using a different technique, and that technique is called the non-restoring. You can see on the screen the name of the technique is called the non-restoring division algorithm. Now before the discussion of the non-restoring division algorithm, previously we have discussed another algorithm that is also for the performation of division arithmetic operation of unsigned integer, and that is called the restoring division algorithm. Now you can see this video link from here. If you have not seen this, you can see from here, and that division algorithm is very much useful for performing the division arithmetic operation of two unsigned number with the help of this. Now this is also another kind of algorithm which will help us to find the divisor and the remainder of two unsigned number. One thing is clear from these two algorithm here is that we cannot perform signed integer division with the help of these two algorithm. We only can perform the unsigned number operation with the help of this non-restoring division algorithm. So first we will discuss the flowchart and the different steps that is required for the case of this non-restoring division algorithm. So okay, so this is the flowchart for this algorithm, and in this flowchart of this algorithm you can see that this is the starting point of discussion or the starting point of this algorithm. Now to perform the division operation, we must know that we require a divisor and the dividend, and with the suppose this is a number, decimal number, and we want to divide this number with 3. So this is your this is the divisor and the dividend in the case of the okay. With the help of these 3 we are going to divide the number, and whatever we are going to get, and that is called the quotient and the remainder. Okay, so that is the divisor and that is the dividend, and this is your quotient and this is your remainder. All of you will get with the help of this algorithm. Now first we will initialize the algorithm, and starting point we will initialize a with 0. We will require different variable for performing this algorithm. First variable is your a, second variable is your m, and after that q, and next is your n, that is your count, and then we will get the result. Okay, cumulative result. We have to perform the different steps. So you can see this is the steps, and after performing all these steps we will get the result. So first we will initialize a with 0. Next in the m you will store the divisor, in q we will store the dividend, and the number of bits, you can see this is step number 1, the number of bits in the dividend, this is your dividend. The number of bits represent this dividend, that is your n, that is your count. Okay, so this step is clear, and next we will check whether this value of a is less than 0. This step is similar kind of in the what we will discuss in the restoring division algorithm, that to find a number whether is a number is less than 0 or greater than 0, for this purpose we will check the MSB of this number. So if the MSB of this number is 1, then we can say that the number is less than 0, and if the MSB of a number is not 1, then we can say that the number is greater than 0. So for that step we will check the sign bit. Sign bit is the MSB of any bit. So we will check the MSB of any number, and this number, if it is 1, we can perform this step, and if it is MSB of that A is 0, then we will perform this operation. Okay, so step number 2 is completed, I think, and after checking this we will perform this operation. If this is 1, we will perform this operation, a shift left and A equal to A plus M. New A will be created, and if it is 0, you will also shift left A and Q, and new M equal to A equal to A minus M. Okay, so that is the checking of MSB condition. Next we will check whether, again after left shifting A and Q both, we will again check whether A is less than 0. Again we will check A will be less than 0 or greater than 0. For that purpose we will also check the MSB of A. If the MSB of A is equal to 1, then we will perform Q equal to 0. We will set Q0 equal to 0, and if it is 0, that means if the MSB of A again is not equal to 0, that means if A equal to greater than 0, then we will perform or set Q0 equal to 1. Okay, so after that we will decrease the count by 1, and again check if the count equal to 0. If the count equal to 0, we will stop here. If it is not, then we will continue again. Continue again means again we will check whether A equal to A less than equal to 0. Okay, and if A less than equal to 0, then A equal to A plus M, we will perform this step. Otherwise, if it is no, then we will stop here. We will stop here means that is your end. Okay, in this condition, this last step will be performed if count equal to 0. If count equal not equal to 0, then we will again loop this whole process. We will loop this whole process. That means again we will check whether MSB of A equal to 0, perform this, and again we will check whether MSB of A equal to 1 or 0, and perform this. Again we will loop this process, and if count equal to 0, then we will only check this step only once after count equal to 0. If count equal to 0, we will only check this. So this has been written down here in language. Then in step 3, if it is shift left A and Q both together, okay, and this is, and perform A equal to A plus M, this step, and again if it is not, then A equal to A minus M. Step 4, again checking sign bit of A, and if it is 1, that means Q0 is 0, and otherwise Q0 is 1, and decrement this value of n means we are going to decrease the count by value 1. Okay, now in the step 7, if n equal to not 0, then go to the step 2. Step 2 means here, if it is not 0, go to the step 2. Step 2 means here, this is the case. Okay, and if the count equal to 0, then we will perform this step. Whether I have said that we will perform this step. If the sign bit of A equal to 1, then perform the A equal to A plus M, and then end, otherwise directly end. Okay, and the register queue, after the performation of all this value, we the main objective of our is to perform the finding the quotient and the remainder. Okay, so from the register queue we will get the quotient, and from A we get the remainder. Okay, so that is the theoretical part. We will also see how this step will going to perform with the help of this algorithm in the next step. Okay, so that is the all about the algorithm. You kindly see the total process. Okay, this is the flowchart. If in the question you are asked to find the flowchart or write down the flowchart of this non-restoring division algorithm, this is the your non-restoring division algorithm flowchart. And if you are asked to write the algorithm directly, then this is your algorithm steps 1 to step 9. Okay, so in the next process we will see a numerical example of this non-restoring division algorithm. For that purpose I have set some variable here, that is your n, and n is, you can easily say this is your n, and then m, a, q and action. M is your divisor, q is your dividend, and result is, after each step result will be stored. So that is the quite similar what we have discussed in the algorithm. Okay, so let's start with an example, and for the example we have choose, okay, dividend. First we have to choose the dividend. Now in the case of the dividend we have select the dividend as 11 and the divisor as 3. Okay, so this is the dividend and this is the divisor, and in the algorithm divisor is stored in m and dividend is q. So this is your 11 and this is your 3. Okay, so in the case of the performing this step, m is your divisor, so you can easily say m is 0 0 1 1. Okay, and for the case of q it is 1 0 1 1. Okay, that is 11, equivalent of 11, and a we have to initialize all zeros with a, this is your 0, and n is your 4. Okay, so this is the step number 1. This is your dividend, this is your divisor, this is the binary equivalent of this, and for the starting of the algorithm we have initialized this with the help of zero. That means a had been initialized to 0. Okay, so after getting all this value in the first step, then we will perform the algorithm. In the algorithm, first step is whether we are going to check whether a is less than 0. A is less than 0, a and is not less than 0. So left shift, and if it is not less than 0, then you can see a equal to a minus m. So we have to perform a equal to a minus m. Okay, so a will be whether you are going to left shift a and q both. Okay, so this will become 1 1 0 1 0 0 0. So this will be your left shifting. Okay, this is your left shift operation. Both a and q, we are going to left shift both a and q together, and then perform in the next step we perform a equal to a minus m. I am going to describe the first step in details, and then it will going to be in loop. A and a minus m, a equal to a minus m, that is the 2's complement. A equal to 0 0 0 0 1, so you can a equal to 0001. I can a equal to your 0001, and m equal to your 3, so 00113. You have to perform this. So a 2's complement of this is 2's complement, so 1101. So after performing 110, so 1110. Okay, so your new a will become, after performing this step, 1110, and this is your obviously 0 1 1. So after performing the operation a equal to a minus m, we can see that this new value of MSB of A equal to 1. So according to our algorithm, after checking performing this step, A equal to A minus M, we will again check the MSB of A equal to 1 or 0. If it is 1, here in this case it is 1, so we set Q0 equal to 0. So at this is MSB of A equal to 1, we set Q0 equal to 0. So that is the step. Then we check whether this count equal to 0. Count is obviously not equal to 0. Then we will go back to this step. Okay. So count will not equal to 0. Count become 3. So we will again left shift A and Q, both these two. So again both left shift this. So your new MSB of A equal to become 1. So if new A equal to become MSB of A equal to become 1, then you have to perform A equal to A plus operation. So according to the algorithm, A equal to A plus M. So after performing A equal to A plus M, so what will be A? 110. Just remember this 110. So 1100, and your M is 0011. So 0011. So it will become all 1. Okay, so it will become, your new A will become all 1, 1, 1, 1, 1, and this will become your Q. Okay, then we will again check whether the MSB of this A equal to 1 or 0. This will obviously 1, you can see. So we will put again this Q0 equal to 0. Q0 equal to 0. So 1, 1, 1, 1, 1, 1, 0 and 0. Okay. So this will become your, okay, and here this count will become 2 in this case. Okay, so here this count will become 2. Again after that we have to left shift that. So 0, 0, 1, 1, and it is all become 1. Okay, okay, and whether this A MSB of A equal to 1 or 0, you have to check this. So this is 1, so then you have to perform, if this is 1, then you have to perform A equal to again A plus M, A equal to A plus M. So just check all 1. So I am deleting this. So this is 1, 1, 1, 1 A, and M is 0, 0, 1, 1. We have to add these two. According to our algorithm, we have to add these two. So if you just add these two, 1, 1, 1 and 111, sorry, it will not 1, 110, okay, 1111, 11 again 0, and this will 11 again 0. Okay, this will be ignored. So 0010. So this is 0010. Okay, okay, so 0010, and Q is this. Then you have to again check whether this MSB is 1 or 0. So here in this case MSB is 0. So just check the algorithm is MSB is 0. Then we have to set Q0 equal to 1. So for that purpose we have to set, sorry, we have to set 0, 0, 1, 0, and we have to set Q0 equal to 1. Okay, Q0 equal to 1. This is your Q0. So this is Q0 equal to 1. Okay, after that we have to again reduce this count by 1. So this will become your 1. So again we have to left shift this. Okay, so 1, left shift hold these two A and Q both together. So 1, 0, 0, 1, 0, 1, 0. Okay, after left shifting this we have to become, we have get this number. Okay, A and Q both left shift. After left shift, then again check whether MSB of A is 0 or 1. It is 0, and if in the first step MSB is 0, then A equal to A minus M. So again A equal to your A minus M. So 0 1 0 1, just remember A is, so here A is 0 1 0 1, so you have to perform the subtraction operation. So for that purpose we have used the 2's complement. So 1 1 0 1 1 1 0 1, we have to add these two. 2's complement of M, this is the 2's complement of M, and this is your M. So after if you want to do the subtraction operation, that means if you want to perform A equal to A minus M, you have to just add A with 2's complement of M, then you will get the same result as A equal to A minus M. Okay, so 1 1 0 and 1 1 1 0 1 1 0 and again 1 1 0, this will be ignored. So 0 0 1 0, I think 0 0 1 0. This will become your new A. Okay, 0 0 1 0. So 0 0 1 0, and this will intact. Okay, this will not change. Then we have to again check whether this will be 0 or 1. So this is 0. So if this is 0, then set Q 0 equal to 1. Set Q 0 equal to 1. Okay. So 0 0 1 0, set Q 0 equal to 1. Okay, we have set Q 0 equal to 1 because MSB of A equal to 0. That's why we have set this Q 0. According to we have to go according to our algorithm. Okay, so now your count becomes 0. Now your count becomes 0. So we have reached the step here. Count becomes 0. So if count becomes 0, again we have to check the MSB of A. If it is 1, then you have to perform it. If it is 0, no issue. You have to just end this. So you can easily see from there that the MSB of A is 0. Okay. Then according to the algorithm, we have to stop our algorithm, end. So and we will get our quotient from Q and remainder from A. Okay, so our algorithm come to end, and here from there this is your Q. You can see that this is your this is your Q. Okay, so I am just making with different color. This is your Q and this is your final A. So according to our algorithm, we will get quotient from Q and remainder from A. So this is the decimal equivalent and this is the decimal equivalent, and previously you can say start of our algorithm 11 and 3. So if you just perform 11 divided by 3, so your new remainder is 2 and new quotient is 3. Okay, so this is your 3 and this is your A remainder. Okay, so you can see with the help of this, this will take a little bit of calculation. In the exam, if you are asked to calculate two numbers, division of two numbers with the help of this algorithm, then you must have to perform this number of steps to get the result. That is another issue, but just see how beautiful the algorithm is. With the help of this algorithm, computer actually perform the division algorithm within the computer with the help of this restoring division algorithm, non-restoring division algorithm, with the help of these different algorithms. So you must remember all this and must know how computer actually performs this. Okay, so I have discussed all the things regarding the non-restoring division algorithm. That means what is the flowchart, what is the different step in a lucid format, and more importantly, I have manually calculated all the steps required. Okay, I can manually calculate all the steps required to perform this division with the help of this algorithm. Okay, And one more thing regarding this a equal to a minus m, I have already discussed. I am again repeating this. If you want to perform this a equal to a minus m, just guess 2's complement of m and add with a. That will become your 2's complement. I have performed this step actually while I am doing a equal to a minus m operation. Okay, so you can practice on your own, but just by taking two arbitrary numbers and verify whether the result will comes or not. Actual result, I think actually obviously your result will come, but instead you can check on it on your own and remember the algorithm to perform it in the exam. Thank you.